Welcome to this video, which shows us how to find the highest common factor, or HCF, or the lowest common multiple, which is called LCM. Today we're going to go step by step through the methods you need to solve the problems you may face that need you to find either the highest common factor or the lowest common multiple. First, we had better quickly review what factors and multiples are. So factors are numbers that divide exactly into another number without leaving any remainder. So for instance, the factors of 4 are 1, 2, and 4. For example, if we think of a large number, let's say factors of 12, we'd have 1, 2, 3, 4, 6, and 12. On the other hand, multiples are what you get when you do the multiplication times tables, for instance. So if we were using 5, the multiples of 5 are 5, 10, 15, 20, etc. Now that we know the difference between what a factor or a multiple is, let's move on to finding the highest common factor, often can be referred to as HCF. This is the largest number that can divide two or more numbers without leaving a remainder. So there are a few ways in which people can find these, but one of the most effective methods is to use prime factorization. So usually this is easiest done by creating something called a factor tree, prime factor tree. And then using that to identify its prime factor. So for example, if we take the number 48, it can be broken down to 2 multiplied by 2, multiplied by 2, multiplied by 2, multiplied by 3, or in short, we can say 2 to the power of 4 times 3. If we were then trying to find the highest common factor between 48 and 36, we do the same thing with 36, so that can be broken down into 2 times 2 times 3 times 3, otherwise known as 2 squared times 3 squared. So once you have all your prime factors, one of the simplest things we can do is to create a simplistic Venn diagram where we can compare each of those elements. So we're going to draw 2 overlapping circles, one of them for each number, and then can place all the common prime factors into the overlapping section. So if there is a 2 and a corresponding 2, we can put that into the middle section, for instance, but only as many as they have in common. Once we've done that, we're going to look at that overlapping section and then we're going to multiply all the numbers within it, and that will give us our highest common factor. So for this example of 48 and 36, the common factors are simply 2, another 2, and a 3. So if we multiply those together, we get 2 squared is 4 times by 3 is 12. Now that we have used the prime factorization method for finding the highest common factor, we can use the same basic method for finding our lowest common multiples. So again, start off with a prime factor tree. This time we're going to do it for the number 8 and 12, and we're going to find the lowest common multiple. So set out your prime factor trees, and then you can see that 8 would just be 2 to the power of 3, and 12 would be 2 squared times 3. So what we want to do is now look at all the numbers in the Venn diagram and multiply them all together. So actually we'd end up with 2 to the power of 3 times a 3, so that gives us 24. The other way to look at it is to identify the largest number or exponent of each number and then multiply those together. So the largest number in either list was 2 to the power of 3, and the largest number of 3's was 1, so it's 2 to the power of 3 times 3. It's just another way of getting that same answer. Okay, finally, sometimes you're going to have very simple questions that just ask you to identify the highest common factor or the lowest common multiple. But sometimes you have more complex questions, and it may not immediately jump to your mind that that's what you're looking for. So when you're faced with these, and you're being asked to find the greatest number that can evenly divide, maybe 2 or 3 numbers, this is where you're looking for the highest common factor. So that's why you're either trying to group or find the greatest number that can divide evenly. When you maybe are asked for synchronizing events or cycles, so it might be that you're looking at a bus timetable and there's perhaps 3 buses going at different intervals, you might be then asked, well, when is next time they're all going to arrive back in the bus station together? For instance, this is where you're looking for the lowest common multiple. So synchronizing events, generally you're looking for the lowest common multiple of your numbers. Okay, I hope that's useful for you, and good luck with finding highest common factors and lowest common multiples.